Today we're going to continue 4.4. Yesterday we were graphing sine and cosine equations. Today we're going to look at that backwards. If you already have the graph, could you turn it into an equation? Before we get started, let's look at a little review of those transformations we were doing yesterday. Recall that your equation is pretty lengthy with a lot of variables in there. Remember that we like to have the b factored out of the parentheses. I've already shown that as factored out. Once it is, let's look at what all the variables mean. Recall that the a is the amplitude. That tells you how far to go up and down from the equilibrium. The b value is the value that's going to affect your period. Remember, that's how stretched out. It's like your horizontal stretch or compression, how long it takes for it to start repeating. To find the period, and recall that the period itself is not the b value. We just use the b to find it. And it's always the parent period. And for what we're doing, it's going to be 2 pi over your b value. As we do other graphs other than sine and cosine, that parent period will not always be 2 pi. The c value is the value that moves your graph left or right. That's your phase shift. And since it's inside parentheses, you always do the opposite. And the last thing, the d value, is your vertical displacement. It's this vertical shift up and down. And it's outside parentheses, so you do what it says. As a quick review from yesterday, can we go through and figure out what the different transformations would be for these examples? Number 1, this is your a value. That's your amplitude. I would go back and I'd say, okay, my amplitude is going to equal 2. That means from the middle it's going to go up 2 and down 2. The other transformation that I see is this minus pi. This is your c value. It's your phase shift. This is going to move my graph right, because you do the opposite, pi units. That's your phase shift. It's going to go right pi units before you ever start graphing it. Number 2. On this one you have a negative value here. We can kind of think of that as a -1. Remember that the amplitude is the absolute value of A. My amplitude is still 1 here. From the equilibrium, it's going to go up 1 and down 1. What the negative does, though, is it's going to reflect it, and I kind of usually put that with the amplitude. It reflects over the x-axis. It's going to flip it upside down. The other thing that this graph has on it is the -2. Notice this is outside of any parentheses. There are no parentheses. This -2 is the d value. That's going to be a vertical displacement, and so the vertical displacement is going to shift it down 2 units. The last example we have here, we've got the negative with the 4. We've got a b value that has not been factored out, and we've got something that's going to be a phase shift. This is a little trickier. Let's go ahead and factor the b out before we write too much here. Your new equation is going to be -4 cosine. Factor out the 2. Remember, that's the same as dividing by 2, which is the same as multiplying by 1/2. That's going to make that become a pi over 4. Once you've done that, you can go through and say, all right, the amplitude is going to equal 4, but because of the negative, it is going to reflect over the x-axis. The b value is 2. I'm going to use the b value to figure out my period. It's going to be 2 pi over b, which would just simplify to pi. That's going to end up being a horizontal shrink because it doesn't take as long for the period to, or for the wave to start repeating. Then I'm going to have a phase shift. After I factor the b out, I can see that this graph is going to go left pi over 4 units before we really start graphing it. Now that's review. Let's try to turn that and use that to take a graph and turn it into an equation. Now I'm going to call this a sine graph. Recall that a sine graph and a cosine graph really look the same, and the only difference would be a little bit of a phase shift. And if I just were to look at this, I wouldn't know if it was supposed to be sine or cosine. I have to tell you, I want it to be a sine graph. The next thing that you're going to want to remember from your sine graph is that it starts in the middle and heads up. And so one wave would look like that, sort of. And it starts at the origin. Looking at this example, I'm in luck because my graph starts at the origin and is headed up. That's a perfect sine wave. What that means to me is that there is not going to be any phase shift on this. It did not shift off the origin. It started the place that it was supposed to. The next thing I notice about this is how high it gets. It only goes to 1 and down to -1. That means my A value hasn't changed. It's just the parent value of a 1. Maybe I should start listing some things. My amplitude. I'm going to pull this from the graph. The amplitude is 1. The period comes from the B value. When I look at this, I'm looking at when does this graph start to repeat. Well, in the parent graph, it would be in 2 pi units, but I can see here that I go clear up, clear down, and back to my starting point in 6 pi units. My period is 6 pi. Now that's not the B, that's the period. The phase shift I already acknowledged was 0. I don't have any. This thing did not shift up or down. It's just 0. The main focus here that I want to talk about is the period, obviously, because nothing else is changing. It's just the period I need to look at. The period helps me find the B value. Recall that the period is equal to the parent period for sine, that's 2 pi, over B. What's different is I used to know what B was. Now I know what the period is. The period is 6 pi. If I multiply both sides by B and then divide by 6 pi, you can see that my B value must have been 1/3. If you know the B value, that's really all I got going on in this graph. I think I can write the equation. The equation would be y equals, my amplitude was 1, so I'm not going to bother putting a coefficient on this. It's a sine equation. And then I like to have my B value factored out, so I'll put a 1/3. And then in parentheses, I would put my x, and then any sort of phase shift I would have. Well, I don't have phase shift, so I'm just going to close the parentheses up. And then I'd put the vertical displacement, but I don't have any vertical displacement. I'm done. That's all I've got. All right, let's try one that has a little bit more going on. I'm going to stick with my sine graph here. And I'm going to go over here and start listing out the different things that I'm interested in. The amplitude. This tells me how far I'm going up and down from the equilibrium. You can see that this is right through the middle. The x-axis is right through the middle, and it looks like I went up 3 and I went down 3. My A value is going to be a 3. The next thing I'm going to look at is the period. The period is how long it takes for it to repeat. And it doesn't really matter where you pick your starting point and your ending point. I can think of a sine wave that starts here at 0 and heads up, and the next time it's there, it's right here. Well, how many units later is that? Well, I could count that out, and it's 1, 2, 3, 4 tick marks. And if you'll recall from this graph, you can see that 4 tick marks is the equivalent of pi units. When I get from here to here, I've gone pi units. And then that's only halfway, though. I got to keep going the rest of the way, which is another 4 tick marks, which is another pi. It looks like my period is 2 pi units. Another way to look at that, and it may be easier for you, is because it's a repeating or a periodic function, it really doesn't matter where you start to see how long it takes to repeat. Here my sine wave happens to be bottomed out. When's the next time that it's bottomed out? Right here. That maybe is an easier way to look at it, because I can start at my y-axis, that's my starting point there, and I can just go to the next time I'm at that same spot. That'd be 2 pi. I can see it there too. The next thing I'm looking at is my phase shift, and I definitely have phase shift on this one. The sine wave is supposed to start at 0, head up, go back down, and come back. What I'm looking for my phase shift is, where is the first place that I see this happening? At 0, headed up. It's supposed to happen at the origin. It looks like mine happened right here. I'm at 0, headed up, at pi over 2 units. Looks like I went to the right pi over 2. The last thing is vertical displacement, and this is any shifting up or down, but since my equilibrium is right there at the x-axis, I don't have vertical displacement. Let's work on that period. Well, I guess maybe I don't need to work on the period on this one. The period is the parent period. It didn't change. It's still 2 pi. If you had to do math on it, it would look like this. You'd say the period is equal to the parent period over b. But since I know the parent period is 2 pi, you can see that the b is going to have to stay 1 for that. Whether we write the 1 or not is optional, but if your period is the parent period, then your b value would have to be 1. Let's write our equation. Y equals, the amplitude is 3. And then I put my sine, and my b value is going to be a 1. It doesn't really matter if it's inside, outside, it's just a 1. I'm not even going to bother to write it. X, and then your phase shift, since it went right pi over 2, I would put a minus pi over 2. And then I don't have any vertical displacement. That's my equation. And because it is a periodic function, that's really not the only possible equation I could have. Instead of going right pi over 2, you could have said that it went right 5 pi over 2, because I'm at 0 headed up. But there's really no sense in jumping way out there. We usually jump to the first spot that we see. The other thing that you might have done differently is you might have said that your a value was negative. Maybe this was flipped. If this was flipped, then you'd actually be at 0 headed down if you wanted to use a negative a value. But then you could see that your phase shift would be a 3 pi over 2. So you could do that. But that's a lot of extra work. Try to keep it as simple as possible. Now let's try a cosine graph. It's really the same thing. You're just looking at a cosine wave instead of a sine wave. You have to remember that the cosine graph starts maxed out, then it goes down and back up. If I'm trying to figure out where this graph starts, I've got to be picking out a maximum. That's what the cosine is supposed to start out at. Let's go find our stuff. Amplitude. How high and how low did this go? Looks like it just went up and down 1, so nothing fancy there. The period. The parent period is supposed to be 2 pi. Let's see how long it takes for this thing to repeat. Remember, I can pick any spot on the graph and then just see when is the next time I'm at that spot. Here I'm at. I like to do it just from the axis. That way I can just look, okay, I started off at 0 headed down. The next time I'm at 0 headed down is right here. It took me 4 pi units to make a complete wave. Even though I know that's not what I think of as a complete wave for the cosine, the period would stay the same. The phase shift. This is the thing where I have to pay attention to what sine, or cosine in this case, is supposed to start out at. It's supposed to start at maxed out and then do the full wave. when I'm looking at my phase shift, then I have to find where is the first place this thing is maxed out. It looks like it's right here at 3 pi. That means this wave was shifted to the right 3 pi units, and now there's my maximum, and it goes from there. It moves right. I could also say that it moved left, but I don't have enough of my graph to see where that maybe happened. I'm typically going to move to the right. And this one again, no vertical displacement. Let's take this period and turn it into a b value. So the period is equal to the parent period over b. 4 pi is going to be equal to 2 pi over b. Multiply both sides by b. And of course, I'm showing all this nice work. You're going to do this enough times that you're probably going to be able to do this in your head. Looks like the b is going to reduce to 1/2. I'll use that in my equation. In fact, that's really the only math I have to do. The rest of it I can just pull. Y equals. The amplitude is a 1. I'm not going to bother writing it. This is a cosine wave, right? Cosine. Factor the b out of the parentheses, and then you'll have x, and then it's moving right 3 pi. That'll be a minus 3 pi. And there's no vertical displacement. I'm done. This is the last one. I'd like you to try this one on your own. Go ahead and pause the video, you work through it, and then come back and check. Let's see how you did. I went through and found the 4 features. Now this one obviously was a trickier one because you can see there was some vertical displacement on it. You have to find the equilibrium of the wave. That's the line that goes through the middle of it. Right here would be the equilibrium. And the amplitude tells you how far you go up and down from your equilibrium. And so from my equilibrium, I only went up 1 and down 1. Amplitude stayed 1. The period was a little trickier. Because this didn't cross at a very nice spot here, I'm just going to find my first nice clean, oh, here's one. This is a minimum. I can figure this out. To get from this minimum to the next time I'm there, looks like it went 6 pi units. The phase shift. A cosine graph is supposed to start maxed out, and the first time this is really maxed out is right here at 5 pi. And then you look for your equilibrium, which was right here. Your equilibrium was supposed to be on the x-axis. It looks like it went up 2 units. The equation you should have had, y equals, I'm not going to bother writing the 1 for the amplitude. It's a cosine equation. Factor the b value out. And then x went right 5 pi. I'm going to do minus 5 pi. And then a plus 2 for my vertical displacement. All right, give this homework a try.